Hello. Today, let's talk about the concept of centroid. Now, we have various centers when we are using a triangle. You can have a centroid, and you can have a circumcenter, and you can have an incenter. So let's talk about centroid today. Now, the concept of centroid is very simple if you understand it from the beginning. Now, the first thing that when you are getting the point of the coordinate of intersection of that is at the centroid point, it is somewhere in between here, is a very simple procedure. Now, step number one is to identify the midpoint. So in any question that you can be given in an examination, it is not a must that you should be given a diagram. It is for you to know that a triangle has three sides and you can get the midpoint through calculation. And in most cases, when you are finding the coordinate, that is an investigation path that you're following, which now tells me that you are dealing with criterion B. Now, let's see what you're supposed to do. So given the three coordinates, the first task is for the student to get the midpoint. And you know how to really get the midpoint. Now, the midpoint of B and C is D. But a student in this case, because you do not have a diagram, then you will be required to calculate. So how do you get the coordinate of x and the coordinate of y? So we can get the coordinate of x and y through the following. So for the x coordinate here, you just add 9 plus -1, then you divide by 2, which gives you 8 divided by 2, which eventually gives you 4. So we're going to get 4. And for the y coordinate, you do the same. You say it is 1 plus -1 divided by 2, which gives you 0 over 2, which gives you 0. That's why we have 4, 0. So you do the same to AC, where you are going to get 6.53. You can also do one for AB, where you can also get the midpoint here. So why have I used 2? For us to get the centroid, you only need the two sides. You don't need the third side. So what else then do you do? For a centroid, what we do is that after getting the midpoint, then you connect the midpoint to the vertex. You see that line? You connect this other midpoint to the vertex. The point at which the two lines meet, that is now what we call the centroid. This is the centroid. So this is the centroid that we are going to find ways of determining the centroid. So what then do we do when we want to determine the centroid? So we are going to follow the following procedure. So that is F. So what is the procedure? Now, one is that a student has to know that given the midpoint here, you have already gotten the coordinate and you have the coordinate of the vertex. And the same case, you have the coordinate of B and the coordinate of the vertex. So our work here is to find the equation of the two lines. You see, you find the equation of BE and then you find the equation of AD. Then after finding the equation, then you solve it simultaneously. So this is what we are going to do. Let's see how to go about it. So one, we have said that we are going to use the coordinates for us to find the equation of the line. So let us start with BE. So how do you get the equation of the line BE? So BE, we must get the gradient. So we must get the gradient of the line. So gradient of the line, it is, you know, it is the change in y over the change in x. What is the change in y here? And we are talking about the line BE. So we can start with the bigger side. So 3 minus negative 1. So 3 minus negative 1 all over 6.5 minus negative 1. So this gives you 4 over, the lower one is 7.5. You know, 7.5 is 15 over 2, which eventually gives you 8 over, that is 8 over 15. This one is the same as this. So what I've done is I've just said 4 over 15 over 2. So just multiply by 2, multiply by 2. So that one goes, then you get 8 over 15. So the gradient of BE is 8 over 15. So this is 8 over 15. So we can easily get the equation of this line. So how do we get the equation of the line? So we just say, for us to get the equation now, and we have the gradient, you say y is equals to mx plus c. So which means that you can pick any easy coordinate. I'm seeing negative 1 and 1 is easier for me. So when y is negative 1 and our gradient is 8 over 15 and x is negative 1, then we can get c. We can get the point C. So what is our C here? So we can multiply 8 over 15. When 8 over 15 is multiplied by 1, you get negative 8 over 15. So you bring it on this side. So what eventually happens is that you're going to get negative 1 plus 8 over 15, which is equals to C. So when you work out this, then you get, because negative is bigger than the positive, then you get negative 7 over 15 is equals to C. So then you get the final equation. So equation will be y is equals to, the gradient is 8 over 15 x minus now 7 over 15. So this is the equation of the line BE. This is the equation of the line BE. So then now we can get the equation of which line now? We can get the equation of the line AD using the same way. So what do we do again? So the first thing is that we get the gradient of that particular line. So after getting the gradient, then we proceed. So for the second part, we are getting that AD, the gradient is 5, as you can see here, 5 minus 0. You can see 5 minus 0, that's for y, and for x is 4 minus 4. Now in such a situation, we are getting it is 5 over 0, which gives you an infinity. It is undefined. So in this when you reach this situation that it is undefined, then you find that this is a vertical line. So it is a vertical line. So vertical line, so the equation is x is equals to 4. You can see x is 4, x is 4. So you just define it as x is equals to 4 because it is a vertical line. It has undefined gradient. It is undefined gradient when it is a vertical line. You can see 4 here and 4 here. So the gradient is so big that we say that it's undefined. So the equation of this line 4 and 4 is x is equals to 4. So now we have the two equations. The first one was y is equals to x over 15, 8 over 15x minus 7 over 15, and the second one, the equation is x is equals to 4. Now then, how do you get the coordinate then? So this one is our equation 1, this is our equation 2. So how do you get the coordinate? So it is only saying that the equation 1, which is y, is equals to 8 over 15 x minus 7 over 15, and then the second one is x is equals to 4. So the second one here is just substituting 4 where there is x, and then this one will give you the value of y. So what then happens? So let us substitute and see. So x is here, so we shall get x by saying that y is equals to 8 over 15 x now is 4, then minus 7 over 15. This gives you 32 over 15 minus 7 over 15. So this gives you, this is 32 minus this gives you 25 over 15, which finally gives you by 5 by 5 3, which gives you 5 over 3. So the value of y at the centroid point is 5 over 3. This is the y coordinate at the centroid point, which gives you 5 over 3. So we can get the x coordinate at the centroid point because we already have y, which is already defined here. So our x is equals to, already our x is defined, our x is equals to 4. So you don't even need to find it. But still, if you substitute y is equals to 5 over 3 here, that is for y is equals to 5 over 3, you are still going to get 4 because that is the intersection part. So you don't need to go far again. You just now say that because you are determining the intersection point, then you get that x is 4 because x already has been determined. X is 4, and then y is 5 over 3, which is 1, 2 over 3 here. So this is the coordinate of the intersection point of a centroid. Okay, that is how we determine the coordinate of a centroid. And then we said that also a student can use calculation to get this particular coordinate. So what do? You can add all these values. For instance, you can say that the x, for you to get the x coordinate, is adding 4. You can see I've added 4 plus 4, that is, this is 4 plus 9 plus negative 1. That is for x. Then you divide by 3. If you do this, you will get 4. And for the y coordinate, you can say 5 plus 1 plus negative 1. So if this is 6 minus 1, which is 5 over 3. So you get that x is 4 and y is 5 over 3. So a student can use calculation, and you can also use investigative in the investigative process. So depending on what you are doing and the criterion that you're handling, you can use various ways. So in a centroid situation, a student can say x1 plus x2 plus x3 divided by 3. You can do this one to prove whether you are right. So y1 plus y2 plus y3 divided by 3. So this one should give you the same coordinate of this centroid point. So after you have worked out, then you can use this one to verify your answer. So what have we done today? In today's session, we have said that when we are dealing with a centroid, it is part of the center of a triangle. And determining a centroid means that you get the midpoint of any particular line, you know, like now you can pick BC, you can pick AC or AB, pick the midpoint and then connect it to the vertex. Pick the midpoint of the second part, connect it to the vertex, and then get the equation of each particular line. So you can get BE and AD, and then from there solve the two equations simultaneously. When you solve them simultaneously, then what you are getting, this will be the coordinate of the centroid. I believe this video will help you to understand the concept of centroid. Thank you.